In this tutorial, I will teach you how to choose which equation to use for different scenarios. So in this chapter, we have two major equations to learn. One is Q is equal to mc delta T, and the other one is Q is equal to NH. Now, let me explain what is Q. Q is the energy. We have to supply energy to change temperature of a substance. We have to supply energy to change the state of a substance. Or if a substance has a temperature decrease, it will release a certain amount of energy. And if there's a substance changing from gas to liquid or liquid to solid, then it will also release energy. And with that energy, we use Q to represent that. Now, there are some terms that you should be familiar with. M is the mass. T is the temperature. Now, it's delta T, so it's the change in temperature. Okay. Now, what unit do we use? Do we have to use Kelvin or do we have to use Celsius? Or does it really matter? Well, one thing that I want you to understand is that for every single degree in Celsius, it is the same as every Kelvin. So since we are talking about just the change, not the absolute value, so it does not matter if we use Kelvin or Celsius. They will both work the same. So in our class, we're going to stick with Celsius because that's what we use usually in daily life. And now we have two big terms. C. What is C? This C stands for the specific heat capacity. Okay? It has a unit of joules per gram times degrees Celsius. So what it means is that how many joules will be needed for 1 gram of the substance to increase 1 degree Celsius. This is what we call specific heat. And of course, different materials, different substances would have different specific heat capacity because their structure, their attraction force may be different from one another. So it may take different amount of energy to increase 1 degree Celsius. Now, what is H? Now, H, we have two different versions of H. We have something called H of F, the heat of fusion. And the other one is the heat of vaporization. So, how do we know which one to use? Well, you can just look at the word and literally take the meaning. Now, fusion may be somewhat difficult to capture the meaning, but vaporization is very easy to understand. Vaporization means you're changing to gas. So, think about what would be changed to gas. A liquid. So, for H subscript V, heat of vaporization will be used to describe a change, the amount of energy required to change liquid to vapor. And in this case, it is going to be, the unit would be kilojoules per mole. So in other words, it is actually the molar heat of vaporization because it is in terms of kilojoules per mole. Okay? And the other one is heat of fusion. Well, since this is the vaporization is between liquid and gas, fusion would be between solid and liquid. Then you may ask one thing. Well, are we using the same number if we go from solid to liquid and liquid to solid? Well, you have to understand the process. And that would determine the sign that we will use for the H. If we are going from solid to liquid, by common sense, you understand that we have to supply some source of heat to make solid to turn to liquid. So in that case, the value, the HF value should be positive. So if going from solid to liquid is positive, that means from liquid to solid is negative, which means that process will release energy. Okay? And the same concept will apply on the heat of fusion. The heat of fusion, the heat of vaporization. The heat of vaporization is changing between liquid and gas. So if I want to change from liquid to gas, we have to supply energy. So the HV value should be positive. If we want to change from gas to liquid, it will release energy. Therefore, the HV value should be negative. So this is how we understand what values to use. Now, when to use which part, which equation? If we only have a change in temperature, okay, which the substance remains at the same state. Okay, let me repeat again. If we have a substance remains at the same state from the beginning till the end, and the only change is the temperature, we will use this equation, mc delta T. If there's a substance that changes its state without changing its temperature, okay, let me repeat. If there's a substance that changes its state without changing its temperature, then we use this equation, Q is equal to NH. Okay? Now, what happens if there's a change in the state and also a change of temperature? So in that scenario, we have to really think about the entire process, because we cannot change both at the same time. We must break the process step by step.